So our next presentation is by Dr. Ryan Fisicaro, and I'm pleased to introduce Ryan. He's one of our 2 5-year clinical scientist research track trainees. Rachel Husseini is the other. Rachel has a wonderful poster out, if you didn't see it in the educational exhibits. And so Ryan, we're very pleased to introduce you. He is mentored by Dr. Joe Malgin, and the title of his talk is Head Impact Exposure and Diffusion Tensor and Kurtosis in the Cerebral Peduncle after a season of high school football. Ryan, come speak to us.
Thank you, Dr. Morris. Yeah, so there are no disclosures. And so the purpose of this study was to determine the relationship between changes in DTI and DKI metrics in the cerebral peduncle and cumulative head impact exposure after a season of high school football in the absence of clinically diagnosed concussion. And with diffusion tensor imaging, we're making use of 2B values in multiple directions to model the movement of water. And with that, we can determine the directionality of that movement with the fractional anisotropy and the magnitude of that movement with the mean, axial, and radial diffusivities. Additionally, we also looked at the NADI tissue model metrics, which model the movement of water, both in, with considerations of an isotropic constraint and also restricted diffusion constraints. And with that, we're able to determine the contribution to the water signal by the CSF with the isotropic volume fraction, as well as the water signal coming from within neurites and the orientation of the neurites with the intracellular volume fraction and the orientation dispersion index. However, because the movement of water and its effect on the MRI signal is not linear with time, we also looked at diffusion kurtosis imaging metrics, as this makes use of an additional B value. And what kurtosis allows us to do is determine the difference between the distribution of water displacement versus that of a completely free and Gaussian system. And with that, we can determine the mean, axial, and radial kurtosis, as well as extend that with the white matter modeling metrics, which work with the assumptions of axons being unidirectional and the intra-axonal and extra-axonal spaces being independent and non-interchanging. So with those, we can look at the axonal water fraction, the intra-axonal diffusion, the extra-axonal axial diffusion, and radial diffusion, as well as the tortuosity, which is a ratio between those two. And so for some of the background for this project includes previous work in our lab that has shown that the accumulation of subconcussive head impacts increases the number of abnormal voxels in the brain with regards to many of these DTI and DKI metrics, as well as previous work that has shown that traumatic brain injury in the pediatric population causes both acute and chronic changes in fractional anisotropy values within the cerebral peduncle. So for our study, we looked at 39 male American high school football players between the ages of 14 and 18 with no significant past medical history and no history of concussion within 1 year of the start of the season. All of the players underwent preseason and postseason MRI. They were instrumented with the head impact telemetry system, and an athletic trainer was available at all practices and games to help identify concussion. So the HITS hardware, as seen here, is a configuration of 6 spring-mounted accelerometers, which are able to record the linear and rotational accelerations associated with the head impact. And what this allows us to do is quantify the head impact exposure over the course of a season with a metric called the risk-weighted cumulative exposure, which is the risk of concussion with a head impact given its linear and rotational acceleration. So over the course of the season, given the number of impacts and the severity of those impacts, we can sum up those risks and derive a single number based off of the linear acceleration risk, as well as the rotational acceleration risk, and thirdly, the combined probability risk, which takes into account both the linear and rotational accelerations. For our image processing, we used the T1 weighted images to normalize to M&I space and segmented with VBM8. We used the DTI, TK, Amico, and DKE software packages on the diffusion weighted images to generate the DTI and DKI metric values. We used the JHU Atlas to delineate the cerebral peduncle white matter region of interest. And for our statistics, we did the postseason minus the preseason values versus RWE with age, BMI, and time between scans as regressors. And for the results of the DTI analysis, while there are no significant relationships with the anisotropy or diffusivity, the overall trends were that of increasing anisotropy and decreases in the diffusivity. When looking at the NADI metrics, we saw significant increases in the intracellular volume fraction with increasing RWE, CP, and linear, and a near significant increase with RWE rotational as well. When looking at the DKI linear regression analysis, we saw significant increases in the mean kurtosis with increasing RWE CP and a near significant increase with the RWE linear as well. And while not significant, we did see trends of increasing axial and radial kurtosis as well. And lastly, for the white matter modeling metrics, while there are no significant relationships seen, there were overall trends of increases in the axonal water fraction, as well as increases in both the axial and radial extra-axonal diffusion values. So, taken together, these results that would indicate that potentially what may be occurring in the cerebral peduncle with the accumulation of subconcussive head impacts is that there is an injury to the axons. And with this injury, there's morphological changes, specifically swelling, but potentially other changes such as beating as well. There does not appear to be demyelination, and the changes that may be occurring seem to be more in the intracellular versus the extracellular spaces. And while the permanence of these changes is not known, the potential significance for this lies in that the cerebral peduncle contains multiple fiber tracts, such as the corticopontine, corticobulbar, and corticospinal tracts, as well as serving as the location of the substantia nigra, which thus has implications for disorders such as Parkinson's and chronic traumatic encephalopathy. And with that, here are the acknowledgements that we would like to make. Any questions?
Thank you very much. There must be questions. Yes, Dr. Chhabra.
Yeah, so it seems like with, at least on the subconcussive level, that there's probably swelling going on. So the water movement is more within the axons and more directional, and thus like the diffusion in the other directions is decreasing because of that.
So FA in the setting of acute trauma can be confusing in that in chronic trauma, the FA values go down, but in the acute setting, it's reported that the FA values can go up or go down. It depends on how long after the trauma it's been seen. Inside this particular study, since these are pre and post season, we don't exactly know how long it's been, since whatever event contributed to what had occurred. But in terms of this relationship with FA, it doesn't always go down. No, there's no hemorrhage in these. I mean, we have SWI images, and there's no evidence of hemorrhage.
So I was interested in the dispersion of values at the low RWE, and
Yeah.
Do you take that to mean that some people are more susceptible?
So I would taken that to mean that with the lower level of head impact exposure, there seems to be a greater variability in what happens with them. But as the head impact exposures increase, it seems like those subjects had less variability. So on the lower end, there might be a lot of other factors going on, such as just previous exposure with other sports they may be playing, or there might be genetic factors as well that we're unable to account for in this.
Okay.
So I have two questions. So did you do any kind of neurocognitive testing of these people, pre and post?
Yeah, so we do have neurocognitive testing for them.
And what happens?
And well, we're looking into that now to see if there's any correlation, like with any changes in that with the head impact exposure. So nothing definitive as of yet.
Okay, and the other, I just have a comment. So there's been sort of years and years and years ago, there was this hypothesis called cytoplastic streaming, where there was active transport of water along axons. Are you familiar with that?
I am not, no.
So that would, that's an ATP-dependent process, and at least in animals, it's been shown to be inhibited if you inhibit ATP synthesis. So the water diffusion along the axon could be a lot faster than you would do from passive diffusion. And depending on how you injure it, you could get almost any answer you wanted to. So the question is what's actually, trying to relate this back to some mechanistic physiological model is probably really hard. So, and you probably need very, very precise data, and I don't know how precise these data are.
One more. Do we have another question? Dr. Rofsky.
So thank you for the presentation. I'm not a mathematician, so I get a little alarmed when I see p-values that are statistically significant in a linear regression with an r² of 0.1. Can you explain that?
Yeah, so at least for what we did, we modeled the changes in those metrics with the regressors, and then we took the residuals and then plotted the RWE versus those. And so those graphs are showing that, yeah, the amount of head impact exposure that they're getting is accounting for, about 10% or so changes that we're seeing in the players. So yeah, obviously not super robust. Like it'd be, if it was like 0.8 or something like that, but.
Well, and so is there another function to map rather than linear? Just an idea.
Yeah, so we can also look at whether they're more logarithmic or quadratic in their change. It just so happened that with this data, it seems to be linear is probably the best fit. Although there's some other projects going on in our labs that show that sometimes quadratic functions, like there's a certain threshold beyond which the changes are different.
Thank you for that important word. I always think the subtitle should be Making Little League Baseball Great Again, right? Or Mamas, Don't Let Your Babies Grow Up to Be Running Backs, right? Thank you very much, Ryan.